Hi, it's Mike from luxblocks.com. Things like this happen in nature and in soccer all the time. This is a Buckyball, okay? And it's basically made out of 20 hexagons and 12 pentagons. These would be the pentagons, and these green guys here would be the hexagons. See the little hexagon right there in the middle? And these 20 triangles, okay, are part of the icosahedron that's part of the Buckyball, because from vertex to vertex, you're going to have triangles form. These are the vertexes here, the vertices, and these are the edges. And so you're going to have 20 of these triangles. So a Buckyball has icosahedral symmetry, a symmetry of 20, and also a symmetry of 12. It's a beautiful thing. Why are these things and things like it, like bubbles, so common in nature? They're so common because they're made out of membranes. So I'll show you what I mean. This Buckyball here is made out of 20 of these. Okay, if you can see that, this is the hexagon I talked about, and each one of these is 1/5 of the pentagon that'll make each node or vertice. Okay, these themselves are amazing little creatures. The way they bend and fold in your hand, you'll just love, because they make beautiful little shapes. Gorgeous, and they seem to have like a little mind of their own. They move in a very specific, cool way. And what happens is when you start putting these together, and imagine this is like maybe the surface of the water in a pond or something. You start putting this together, they start acting again even more in more interesting ways. They act like a wave, like if you put your hand in the water and all the water gently moved up and down and undulated like a wave in the water, okay? That's because this is acting like a membrane. And the surface of a water is like a membrane. If I put 3 of these together, it's interesting. If I put 4 of these together, it's nice. And 5. Now, if I put 6 together, it will remain very flat. It'll still be wonderful, but it won't form into a Buckyball. I do this. This is an awesome shape to play with. This is great, okay? But it won't form into the pyramid here that makes the Buckyball. These are a bunch of pyramids that all go around into a ball. And we talked about that in our section on pyramids, how hexagons will not make pyramids. It takes a pentagon to make a pyramid. Hexagons remain flat because they're using all 360 degrees, and 360 degrees is flat. But if you subtract 60 from this, you're going to get it rise up. And that's basically what the forces that are happening when you think about a surface like water with maybe soap on the water and gas underneath pushing up on it, and you're going to have a break in this film. Can be forced to break, and it doesn't break in just any way. It'll just substitute a triangle, and it'll fold up into a pyramid. But bubbles happen so fast that you don't see them first turning into pyramids and then turning into half of a dome and then turning into a sphere, then popping out of the water. No, that would be very, very slow motion. So here you have the first part of this. I can put it right over that so you can see. See that? Just disappeared there. So that is, I'll put a hat on it, see that? That is part of this. That's why these are so common, because it's just a gas going through a liquid will make these guys, okay? Or if the Buckyball, it's a microscopic molecular form actually of carbon. Okay, there's diamonds that are pure carbon, and there is what's the other one? Benzene is pure carbon, graphite's carbon, pure carbon, and then there's this. Buckyballs. Actually, benzene's not pure carbon, but graphite's pure carbon. So this is just one of those things that it's easy for nature to make, okay? And talking about carbon again, Buckyball is like this, but another form of carbon is graphite, which you use on your pencils. And graphite is like we just talked about. It's that hexagon shape. And graphite comes in these sheets of hexagons. And what happens is when you draw with a pencil, the sheets are all layered on top of each other. And when you draw with a pencil, they actually will peel and flake right off, and little hexagons of carbon will be, graphite will be on your paper, okay? There's just sheets of these hexagons, okay? But Buckyballs are when the forces at B make the carbon into a ball instead of graphite. So it forms like this. which is awesome. And then I can start adding more and more and more of these. I can put 5 more on, like this. You see how the white ones always share the corner. The whites share, they share the whites. Another one here. Let's see. Oh, here. It gets very much like a starfish. And another one here. And just very, very starfishy, if that's a word. Because you get this nice creature here. I call these creatures because they act like creatures. They are creatures because they're created. But look at that. This thing actually moves. It actually moves exactly like a starfish. And this is how starfish actually move. So it's very membraney. But now, you remember we talked about membranes? Now the membrane has been given an order. It's been given a structure. So the membrane will have its own language of motion. And it'll be very reminiscent of what you've seen when starfish move around. Okay? Now, here is where we start closing it in. We have, look at this, we have one, if you can see it, one triangle here, 2, 3, 4. So we're only going to put one more here to make it 5. We're not going to put 6 because then it'll flatten it out. Put this final one here. It's going to fold right around into another pentagonal pyramid here. So you have a pentagonal pyramid here and here. Look at that. We'll put another one here and finish this because we have one. We can't count. 1, 2, 3, 4. Add one more. And you're just going to start seeing that buckyball or the soccer ball forming here. Zip it right up. See that? Wow, it's really starting to come in. We can just put this right on top of this one if we wanted to. Look at that, right on top of it. See that? It's really forming. 1, 2, 3, 4. We need one more right here. They're actually very easy to make once you make parts. I put one finger underneath to give it support. I always do that. Try to put, if you can, put one finger underneath. It makes it a lot easier. Here, 1, 2, 3, 4. Put another one here. You see what's happening? Now I have a pyramid here, pentagonal pyramid, pyramid here, pyramid there. It's really getting round now. The whole thing is getting round. We have an opening here. We're almost done. So we'll put one. Oh, there's one missing here. So we'll put one here. And you'll start to feel it. It really is a shell. It becomes like a shell. It gets harder and harder. It's still squishy, but it's hard. It's got much more of its own form now. It's not totally squishy. So you're moving from membrane to shell. Now it's like a little dome. It's actually got a flat bottom. See that? It'll stand like a dome. And geodesic domes like Epcot Center are based on this geometry. So if we wanted to finish it, we'll need one more, and you'll see where it forms right here. You're going to need one more pyramid that fits perfectly right on top. I can make that pyramid now and show you. So I got this opening here. I'm going to make that pyramid right here. We can put the pyramid right on top. Make the pyramid. Boom, comes right up. That on there, we go, and here, and here. So there, and that pyramid would go right there on top, and you'd finish your icosahedron. So that's how you do it. That's how you make an icosahedron out of 120. Is it 120? Yeah, it's a 6 times 20 is 120. So 120 of the greens, the hexagons, and then another 60 of the white. So 180 trigons make one buckyball like this. This is Mike from luxblocks.com. See you next time.